In this video, I'm going to tell you or show you how to create your own flags in Atmel Studio, how to set and clear flags, and also how to test the flags to determine if they are set or cleared. So let's get to my Atmel Studio program. I've already written this program, and what I've done here, first of all, I have created a char here, unsigned char, which means what I've done here is actually created 8 flags. So as a starting point, I am saying let's assume the flags inside this char, the upper nibble is set, meaning all ones, and the lower nibble is 0. So it's just to show you that if I make some changes, I will not affect the bits, the rest of the bits. I've also declared this as volatile. Now I see there's a lot of confusion about this whole thing about volatile, but it's basically very simple. If you want to optimize the C program, it is possible that registers can at some point give different or wrong answers. So if you declare it as volatile, data will be moved like it's done in assembly from RAM to registers and then from registers to RAM, and those steps will not be skipped. So this is why we use volatile. So what I've done also here is I have created, I've defined flag A as 1, and eventually you will see that flag A is actually going to refer to bit number 1 in all flags. Then I've also defined something here by the name of flag B, and I'm also going to refer to bit number 6 in all flags. What you see here, I've just created a constant here, a constant char, unsigned char, because I just want to show you certain things in my program, and this is why I've done that. So I am at this stage. Let me just get to the point where I can just get to debugging, because I want to show you the changes that will be happening. So in this specific instance, the first thing you must realize is that when you see something like this, 1 smaller than in this case flag, which is actually a 1, that means this is a constant value. This constant value actually looks like this, where if you see this 1, it means there will be a 1 placed in this position, because flag A has been defined as a 1, it means that 1 will be placed there. And this is why once I go through this, if I step through this one here, you will see that constant 1 will be sitting with a value of hex 2. Let's do that and see if that is true. And there you can see it at the bottom. Constant 1 changed to a value of 0.2. So if you see something like this, this is just a straightforward constant. You could have put in here 1, that will be referred to bit number 1, and if we go to flag number B, if you put 6 there, it will the result will be exactly the same. So what I'm going to do now is I want to show you how can I set flag A, which is actually, remember, in all flags, if I go back to all flags, the lower nibble are all zeros, which means bit number 1 is also a 0. So how do I set flag A, which is actually bit number 1 in all flags? This is the statement that we will be using for that. You will take all flags and you'll OR that with the old value of old flags, and then with this constant as I've just explained here. So let's have a look at what's going to happen in this specific statement. So all flags, we've seen that before, it's F0, there it is, and it will now must be ORed with what we have here, which is a constant, and we know by now that this one is actually this one that's been placed in bit number 1, which is that one there. So if you start ORing this, if you've got all 1s here and all 0s here, you will see that the result will of course be the upper nibble all 1s. Because of these 2 zeros here and that 1 0 there, 2 zeros there, 1 0 there, let me just get back. You will just see that only this 0 and that one, if ORed, will basically change that bit. So let me just step through this and let's see what we have in all flags. In all flags, we are sitting with a value of F2. And this is exactly what I've shown here. You will be sitting with F2. So what has happened? I have only set flag A. I did not change any of these, the bits 4 to 7, or even bit 0, or bit 2, or bit 3. I did not change them. So I only, by making use of this statement, I only changed this one specific flag without affecting any one of the other ones. So let's have a look now at this next one. You already have the picture, because if I say place a 1 in flag B, which is actually referring to bit number 6, that means there will be a 1 in bit number 6. This refers to a constant, so that's your constant that you see there. If I step through this, you will see that constant 2 will actually go and sit and have a value of 4 hex in it. Let's do that, and there you go. It has got 40 hex. It has got 40 hex in it. Now let's look at this one. So what are we going to do here? We saw that this is the way to set a flag. This is now the way how you will clear a specific flag. Previously, remember, all flags, the upper nibble, are all ones, meaning bit number 6 is also a 1. So if I want to clear that specific flag, and normally this setting of flags or the clearing of flags, that will happen in maybe an interrupt service routine. You'll make you'll set the bit there, you'll clear the bit there, you'll go back to your main program, you'll test for those bits, and once you get to the bit, you'll make use of while statements, or you'll make use of for, or make use of ifs, and then again at some point clear or set flags. But this is the way to set or to clear a flag. So in this specific instance, now if I want to clear a flag, I will definitely say you must AND it. If you want to AND, and also we need to use the tilde there. So again, we know inside this brackets, what we have there is actually place a 1 in bit position number 6. So that's just a constant. So there it is. So the tilde in front of this, let me just go back to this one. This one here is what we have here as a comment. So this is exactly what's inside the brackets. This is the tilde. This actually means go and complement each and every bit. So once you complement each and every bit, all the zeros will become ones, and this 1 will become a 0 there. So let's have a look now. So what we've done here is just this part. So now I need to AND that with all flags. And this is all flags from the previous. This was what previously was sitting at all flags. This is all flags sitting here. And I need to AND that now with this value that we are sitting here with. So if you start ANDing, whenever you see zeros, the result will be zeros. When you see a 0 there, the result will be a 0 there, etc. So at the end of the day, what was the purpose? It was to clear flag B. So let's have a look at this thing. The only change that occurred from previously was that flag B is now all of a sudden bit number 6 flag B in all flags is a 0, while I did not change bit number 7 or bit number 5 or 4 or any one of the rest. So what you see here and the previous one there, it's exactly the same thing. In the next line, let me just go in step, and you will see then that all flags change to B2, which is what I've said here, B2, which means only that specific bit actually changed or cleared. This next statement here is actually to test a flag. In this specific case, I want to test if flag A is a 1. This is what I'm doing. So the way I'm going to test for a 1 in a flag is with this statement. So I will take all flags and I'll AND it with, and I'll mention flag A here. So let's have a look at this now. So if I take this thing, all flags, we know all flags is this. We've seen that from the previous, from that section there, or that statement there. And we know by now that inside this is just a constant value, which is what we see here. And if I start ANDing this Where I've got all zeros, it means the upper nibble will all be zeros. The only place where I'll find a 1 is because but in all flags I've got a 1 there, and flag A, the constant position, is also a 1. So this is why I'll submit the 1. So this answer that you'll be sitting here is actually a value of hex 02, which means this is what you see there. If this is a true value, in other words, anything above 0 is true. So if this is true, it will actually then go into this statement here. Let's see if that is true. Let's have a look. If I step, you can see it now tested. In other words, yes, we know the flag was set, but this is just the way to test it. So going in here, in this specific case, we've seen it before. It's now quite easy to clear a flag. How do you clear a flag? You say, let's have a look at all flags. Let's AND that with the inverse of this constant. And this is exactly, we have got this in all flags. I want to clear. In all flags, it's actually that bit is my flag A. So I want to clear that specific, this single bit here. This is all flags. I'm ANDing it with, well, basically the inverse of that section, which is actually this one here. And if you start ANDing, you will see wherever you got a 0, you'll sit with a 0. So those two zeros will definitely bring a 0 there, and that's a 1, that's a 0. But the main thing that happened is, if you look at this, all flags was this, and now the upper nibble is not changing at all, and the lower nibble, only that one bit, only this one is actually changing. And this is what I wanted to do. I wanted to clear flag A, which is exactly what happened. So let's go to the next statement. In this one, the previous one, I tested for a flag if it's a 1. Now I'm going to test for a flag if it's a 0. So in this specific instance, I will again take all flags, which we know by now the previous value was this one, which is the value that you see there. And this is a constant, where the flag B is a 1, that one there. And if I now AND the two together, those two together, of course, wherever in the lower nibble all zeros, lower nibble all zeros, meaning lower nibble will be all zeros. If you look at this, bit number 4, 5, and 7 is zeros, which means 4, 5, and 7 will be 0. And this one in 6 is a 0, which means that will also be a 0. So this whole answer here is a 0. The question is, in the statement, is this section equal to 0? And the answer is yes. So the statement is true, and this is why we will jump into this one. You can see if I step now that I will be jumping in there. And as we've seen before, if I want to set a specific flag, the way to do that is to OR that specific position inside all flags. In this case, it's position number 6, or we can also call that flag B. So all flags is this. If you OR all flags with this constant, you will see that the only bit that has changed is that one, which is bit number 6. The rest of the bits remained exactly the same. I'm only setting flag number B. And this is how you basically, let me just step here, and you will see that all flags definitely made that change to F0. There it is, F0. And this is how you can actually create flags in a register. You can definitely set a flag. That's the way to set a flag. You can definitely clear a flag, and you can also test. You can also test for a flag. Here you test if the flag is a 0, and here we're testing if the flag is a 1. So I hope this will help you to better understand how to test and clear bits, how to test for it, and how to set up your own flags. Thank you.